Here is just a short recap on what we are talking about. We want to operate microprocessor boards with a solar generator and a battery. From the last video we learned how to use the simulation tool on the spreadsheet, and we got a number of interesting learnings. Now the part 2 is here, and we go immediately ahead with interesting simulations. Engineers don't want bad surprises. That's why they want to look ahead for the worst case. We are doing exactly this in the following situation, so that we can calculate a rock-solid design for our solar generator. Furthermore, we look at the power consumption of so-called low-power boards, and we will see that these are giving us complete new degrees of freedom here. We are back in our simulation tool now, where we found a design that seems to be okay for over all the seasons of the year. Now we are going to our variation simulation. We say that our uncertainties from our estimations and the degradations can be 15% maximum. The resulting energy budgets in the right window are still okay for this case. Very good. Now we are going to simulate exceptional things, like shading through snow, leaves, etc. First we try out 100 mAh loss, which is less than a day's consumption, as we can see from the middle section here. The energy budgets are still looking very good, so that we can afford more here. Next we take 400 mAh, which is almost a 3 days consumption. Obviously this would be the limit that we can afford if we want to guarantee a stable operation during the seasons. The battery state of charge is almost reaching zero during the winter. Of course, only under the assumption that the exceptions that we defined will happen. After all, we can summarize that we found a decent configuration for our solar powering. Congratulations if you made it up to here, because now the most interesting part of the simulation starts now. We are considering now so-called low power boards. For this we need to go back to our consumption inputs. We consider now 500 microamperes instead of 6 milliamperes. Good load power boards can go down to about 400 microamperes or much less in the deep sleep mode. The energy budgets are showing us that we are more than good now for the whole year with this. Now let us see which additional degrees of freedom this is giving us. First we are going back to the solution with the one small solar panel. And we are still very good. Maybe we can use it also in a much more shaded place. This would open up a lot more options to mount our solar panels, being less exposed or even less visible sites. Let's play a bit with that number. Cool, we can go down to 15% and are still okay. The power budgets look even better than in the case before. Of course, we also want to see the variations calculation now, as we did in the case before. We also use the 15% for the uncertainty calculation, which is no problem at all for the power budgets. A loss of about 100 milliampere hours would be a consumption equivalent of more than 4 days. Nice result, isn't it? Let's put it that way. Using a low power board, we can achieve sufficient energy from a solar generator that hardly sees the sun. Very cool. We briefly recap the learnings of part 2 now. Our tool helps to create a solid design for a solar generator that is overcoming all seasons and exceptional variations. Depending on the power consumption, the size of the solar panels and the size of the batteries can be an issue, especially when these are limited by the budget. However, these problems are blown away if you are able to use the deep sleep mode, especially with low power boards. Hope you enjoyed the small lessons, and don't forget to download the tool and make your own experience with it. Have fun! Now stay tuned and don't forget to subscribe and support the channel. See you soon in the coming episodes.